Let me quickly share my screen, guys. Okay, yes. So the screen is visible, everyone? Yes, please, guys, please let me know if there is any question, anyone. In GridSearch CV to hypertune parameters, every algorithm has its own parameters. Random forest knows. SVM had C and gamma. How can we know which algorithm needs specific parameters, which parameters I have to pass in which algorithm? That is something that is while like which algorithm needs to be given what parameter, that is something we discussed by the algorithm itself, right? When we were discussing the algorithm part, when let's say we talked about KNN, we discussed that there is a n neighbors in KNN, right? We talked about SVM, we talked about that, like there are C and gamma in SVM. When we discussed that random forest and other algorithms, we discussed this thing also in random forest. We have max depth and minimum sample leaf node, right? Yes. So that is the only way we need to remember what are the parameters for what algorithm, because the parameters are going to be specific for a given algorithm, and parameters plays an important role. Basically the parameters play some important role in their training, right? So we discussed every parameter at the time of discussion of that specific algorithm itself, like what is the process, how this algorithm is working, and this is the parameter and how this parameter is going to impact the training. No module name xgboost. In that case you need to install xgboost. If you are getting no module error, you need to install xgboost. Pip install xgboost, conda install xgboost. You can simply execute the command pip install. Wait. So install, you can simply just google the query, you will get the command install xgboost in Anaconda. Okay, it will simply give us a command. So for Linux, OS and Windows, this is the command. You need to execute this command in your CMD, command prompt, terminal, or whatever you are using. For null values, we use it shows all null values in every column. Is there any such attribute of the function to find the? No, we don't have to find the outliers like this. No, there is actually no such function for the outliers. There is actually no such function for the outliers. Okay. Yes. Anyone? Anything else? If you are getting module not found error, if actually you are getting the module not found error, you need to install xgboost by this command. After apply please PCA, we have limited columns. How do we know column heading which is significant? Oh, like, yes, guys. Anyone wants to answer this question? After PCA, after PCA, what we receive at the end? Yes, guys. What we receive as a result after we implement the PCA? Principal component analysis. Anyone? Yes, when we run principal component analysis on a data set, so principal component analysis will give us the data in a reduced dimension. So what that reduced dimension is? What that reduced dimension is? Is it some column out of the existing data or what? We have 784, we have principal components, right? We have principal components, PCs. Yes, and principal component will not select or drop any significant column. Yes, guys, principal component will not select or drop any specific column. Rather, principal component generates entirely new features, new components, which which will explain the data. There will be a new linear components that will try to explain the maximum possible information in the data with zero multicollinearity. Not columns, principal components. When we transform a data into principal components, we cannot read the column significance after the principal component, right? We cannot read the column significance after doing the principal component because principal component is not going to work on a specific columns. It will simply create a new component. The first principal component is the combination of all the columns. There is nothing like the first principal component has something specific to explain in column 1 or column 2 or some certain column. The principal component is a completely new feature, a linear component that has the information related to all the columns. So whenever we do the principal component analysis, we cannot read the information about each and every column. Yes, we can apply linear regression. Try to understand what principal component will do. Try to understand what principal component is actually doing. It is simply transforming the data with removing multicollinearity and saving maximum possible information in it. That's it. Right? So now instead of using the columns, we are using the principal components. If you are getting file not found error, that's just because the Python, the Jupyter notebook is not able to locate the CSV file, right? Yeah, sure. Just a sec. Just a sec. Yeah, you're good.
Hello. Is
Yeah.
it audible?
Yes,
Hi.
yes, you're audible.
Okay, I just tried one of the first project, I think it is Mercedes-Benz project.
Mm-hmm.
In this, there were around, I could say more than 300 to 400, close to 400 columns are there. After
Okay.
applying the PCA with the 0.95 percentage, I got the size as a significance is with the 5 only. Means that I got the significance with the 5 columns.
Okay.
Okay. I'm not saying which column it is. I understand what you said. It is a principal component. But this 5 column after that, I try to apply the linear regression. And after the applying the linear regression, the accuracy of the model is coming only less than 4%.
Okay.
So I have a doubt because the score is very less. The
Yes.
accuracy is very less.
Yes.
So I thought, is it the right way of doing it? Because I think in our sessions we have only stopped making the PCA, but after that we have not realized making the model out of the PCA data.
Okay. Okay. Which one was the data set?
It's Mercedes-Benz.
Mercedes-Benz. Okay, from here, from the suspend itself, right?
Yes, yes, correct.
Okay, so around okay, after doing the dimensionality detection, it won't be four. If I remember it exactly, it won't give the four principal components.
No, it gets around the 378, I think. 386 were there. But see the significance we are talking, right? The significance, if I say 0.95, it can be the significance of the columns itself is coming around the 5 to 6. Okay.
How exactly we are calculating the significance?
Significance in the sense of the cumulative sum, I mean, after the PCA, with the variance ratio, I try to calculate the shape, and other than this.
Okay, so that is not actually the significancy. The cumulative sum of explained variance ratio is we are trying to count the number of principal components that are explaining 90 to 95% of the variance. So if we will try to do variance, let's say var percentage is the array that carries the explanation, the percentage of the explanation. The cumulative sum of that explained variance ratio for all the principal components. We need to count the number of principal components till cumulative sum is less than 0.95, and I believe that should not be 4. 4, if we are getting 4, then there is something wrong. Like there is some error, or there is something wrong.
See, I think this is the code I used to do, and then I got, when I make the shape, it was showing as 5, because I see it not.
Okay, it was 5. Anyone else, guys? Anyone else tried the same thing? Okay, 217 PCs. Yes, that sounds little practical, because getting 4 is, I'm little doubtful that 4 should not be the result in that case. Okay, so if this is about the project, let's discuss the project at the end. Will that be okay? Let's do the unsupervised. We will talk about the project in some proper session.
Sure, sure. But the question was, after PCA, with that whatever the variance data we get it,
Yeah.
we can apply the model and
Exactly. That's not a wrong approach. We can definitely, the way we can use the columns to apply a model, we can definitely use the principal components to apply a model, and basically that's what is being told in this project itself. So we can simply transform to the principal components, and we can use those principal components in place of the X where we use linear model.
Okay.
So that's completely correct.
Sure, I will recheck my code.
Yeah, or we will also try to see why what's the issue and how many principal components we will be getting on this specific data. Okay. Yeah.
Okay.
Please let me know if there is anything else. Yes. Oh, we did the horses case study. Then we talked about the Big Mart one, right? We did few case studies. We'll discuss about the pipelines if we get time at the end of the session. So pipelines are not actually included in this program, but if we get some time, we'll discuss about the pipelines and estimators also. No, that's the machine learning right now. Like whatever is mentioned, if you can just go to the self-learning section. These topics are something what we are discussing here. This is the syllabus of this program, and AI is not here right now. AI is not here right now. Okay. Yes, definitely. We will cover about the pipelines, and we will also cover about the other important topics. We will definitely cover the pipelines and other important topics as well. No, we actually cannot convert to XC directly this way. We need to write a Python file, and that Python file should be having the same architecture to take the parameters and other things, but directly we cannot compile it to .exe. Perfect. Now we are going to start the unsupervised learning, in which we will be talking about cluster analysis or clustering algorithm. Okay. So first of all, let's understand the clustering, and then we will see what all algorithms are there for the clustering. So in clustering, we have two types of algorithms, k-means and hierarchical, and these are the two different methods to cluster the data. Clustering, in terms of data science or in data science, we refer to group the data observations without any target in consideration, right? We do not have anything as a target that we want to group the data with respect to some specific target value. No, it's not like this. We simply create the clusters with everything what we have. We consider that everything is important and we should not drop anything. So the significancy criteria, the significancy term is something that we don't use, right? The significancy criteria or significancy is something that is not applicable in unsupervised machine learning because we don't have the target variable in consideration, right? There is no target variable, so we can't calculate the significancy. We assume that every information is important. Let's say we have 100 columns. So whatever is the variance of all those 100 columns, we should be working on all the information, right? We cannot drop those columns that's not significant because there is nothing to check significancy for. Make sense? Make sense? So, so what is the clustering? Simple. Creating the groups of the data by considering all the possible columns, all the possible information what we have. In case of huge dimensions, we can only use the principal component analysis to reduce the dimension and remove the multicollinearity, right? Reducing dimensions by PC and removing the multicollinearity is something we can implement, right? In case of unsupervised approach as well. Yes, guys? Perfect. So in significancy, or sorry, in unsupervised machine learning, we understood the clustering is all about making the groups of data. Yes? By name only? I'm sorry, I didn't get by name here, but what's the name? We understood it is grouping data. Yes, we just need to group the data. We just need to group the data with respect to each and every information we have. Yes, without target, without any specific uh, goal. Like we don't have something. For example, we want to group our customers. So we want to group the customers by each and every information we have about their customers. We don't want to group them with respect to the amount what they are spending. We don't want to group them with respect to the products what they are purchasing. So if we are grouping it with something in target, that's not a clustering in that case, right? We want to group them with everything whatever we have without any target variable. Correct? Brief all the importance we have in the unsupervised. We'll talk about that at the end. Let's discuss the algorithms, then we will see. Perfect. What is clustering? Clear, everyone? Perfect. So let's discuss the first method of clustering, that's called k-means. Let's discuss the first method of clustering, that is the k-means clustering, right? Now in k-means, let's suppose we have two variables x1 and x2 and we want to group data with respect to the x1 and x2. Okay, let me plot some data samples. Let me simply plot some data samples. Now in this data, the group is not actually, we are not having something like a group here, but yes, now it looks like we actually have a grouping, right? We actually have a grouping in this data. Perfect. So let's understand how the k-means clustering will work. So in k-means clustering, we just need to tell, we actually need to tell the algorithm how many clusters we want to create, right? How many clusters we want to create. Let's suppose we have given two clusters here. Okay, let's suppose we have given two clusters here. So it will pick some two data observations randomly. It will pick two data observations randomly. Now let's suppose it picked this and it picked this. So there'll be two random observations. It can pick any of them, right? It can pick any of them. So if the two observations are far, like this and this, then it's actually easy to create a cluster. But let's suppose the two observations it's picking are very close. We said create two clusters. It will pick any two random observations as their central point in order to create the clusters, right? Any random two observations. So these two observations can be any two. They can be these two also, these two also, any two random observations. Clear? Okay, perfect. Now it will create clusters. It will create clusters by referring to these two random observations. So this is closest to this. If we observe this data point, it is closest to this, right? If you observe this data point, this is closest to this. Yes? So based on that, the clustering will happen. Based on that, the clustering will happen. And we can see the clusters are not accurate right now. The clustering happened, but the clusters are not accurate right now. Yes? Understood how this clustering happened? Two random observations, calculate their distance and everything, and based on that, put the data into a cluster. And right now the clustering is not very accurate here. After this, what it will do, it will try to calculate the centroids, means the mean of all the observations. So for this data, here somewhere we will be having the centroid, right? Yes? Yes? Centroid makes sense? Okay. Now the next observation it will pick for creating the clusters will be close to the centroid. Something close to the centroid. Okay. Now for the next time there will be something close to the centroid. So suppose this was the centroid, this is the second observation, and here this is the second observation. Okay. Now it will create the clusters again based on these two new observations selected that were actually close to the centroids. Okay. Now on these two we will be getting some better clusters now. This is the iteration 2 and now we will be getting some better clusters. Okay. Now these are the two observations selected for creating the clusters. Based on that, we will calculate the distance and everything. And now this will be a kind of cluster we will be getting, right? This will be a kind of cluster we will be getting. And see, we are actually getting, more closer to the accurate results. Yes, guys? We are getting closer to the accurate results. Yes. So this was the second iteration. This was the second iteration. We already have implemented the first iteration, and then we have followed the second iteration, and we get more correct results. Now again it will calculate the centroids. Again it will calculate the centroid. Let me erase the previous centroids. Okay. Again it will calculate the centroids of the clusters. Yes. Yes. And again it will pick another observations close to the cluster, and again create some another iteration for the cluster, right? So see, yeah, after some number of iterations, the centroid will stop changing, right? After certain number of iterations, the centroid will stop changing. Yes. Yes, makes sense. After certain number of iterations, the centroid will stop changing. It won't change anymore. Yes. So we always give the number of iterations a bigger number. By default, it's 100. 100 is the default value, right? But still, if the centroid is fluctuating at this 100 also, we can increase the iterations. If the centroid is still changing, we can increase the number of iterations, but like we actually don't need to change it much. Hundreds are more than enough, and in most of the data set we get a ideal cluster model on 100 iterations only. So this is how k-means clustering works, right? This is how the k-means clustering works. Easy, guys, everyone? So yeah, sure. Let me just brief it again. What's happening? We picked some two random observations. We picked some two random observations. We created clusters on those two random observations. Suppose the two random observations are not accurate. They are not actually in the right cluster, so we won't be getting a right cluster model in the beginning. We won't be getting the right clusters in the beginning. In that case, we will calculate the centroid of the clusters and pick another two observation closer to the centroids. And again, it will create the clusters based on the observation closer to the centroids. This way, there will be more accurate cluster model, like we have observed in this, right? In second iteration, we had more accurate cluster model. And similarly, this thing will keep on going until we get like for the 100 iteration, 100 is the default number, 100 is more than enough also. So after some number of iterations, the centroid will stop changing, means we got a stable and a good cluster model. Easy, the k-means clustering. Yes, guys, the k-means clustering is easy. Exactly, it is necessary to include each observation. Why would we remove anything? We definitely need to include each and every observation for making a cluster. We repeat iterations to increase. There is nothing like accuracy in unsupervised machine learning, because we cannot compare either we are correct or not. So there is nothing like accuracy. We just want to make a model. We just want to make sure that our cluster model is good. But see, if the cluster model at certain iteration also, if you execute it again and again, and we are getting different results, means the number of iterations are not enough, right? See guys, if we create a cluster model on the same data again and again, and we are getting different results, that means the cluster model is not stable right now. That's why we are getting fluctuations in the cluster, right? Yes, default is 100. Default is 100. Does this make sense? When we create a cluster model on a given number of iterations, and suppose we execute it again and again on the same data, we get different clusters every time. Yes, we get different clusters every time, right? And that means we are not actually achieving a stable cluster model. The number of iterations are not enough. Yes, guys? Is it clear? Is it clear? The iteration thing is clear, everyone? Okay. X1 and X2 are the independent continuous variables here. They could be independent, dependent, they could be having the categories, anything. X1 and X2 are some information that we need to include in order to create the clusters. So if we talk about properties of a customer, that could be categorical, that could be continuous, anything. So X1 and X2 are some numerical column based on which we want to create the clusters. No, it's not necessary that cluster needs to have same number of observations. It is very much possible that the clusters have an even number of observations, and that also something perfectly fine, because whenever we create a cluster, it's not always like we are having the same number of observations in every group. Suppose we can pick any practical business case. If we want to create a customers with respect to the product category, it's not necessary that we have equal customers for every type of product, right? What does these dots indicate with respect to the x1 and x2? That's the basic coordinate geometry. If I use blood sugar and pulse rate, blood sugar and pulse rate of, let's say, the patients. So let's suppose the blood sugar of some patient is this, any XYZ value, pulse rate of that patient is this. So this is where that patient will be plotted in a coordinate geometry. Yes? Clear what these dots represent with respect to x1 and x2? We'll discuss how do we decide the number of clusters. There is a separate method, there is a separate algorithm, a different elbow curve method to decide the number of clusters. So we'll talk about that. Yes. So how exactly k-means clustering works? Is it clear, everyone? The iterations and the way, the method, how the k-means clustering will work and how it will give the clusters. Is it clear, everyone? Okay. Okay, perfect. Now, after this, we have the another method of creating clusters. That was the first algorithm, k-means. The second algorithm is hierarchical clustering, right? Now, how does hierarchical clustering works? Suppose we have 100 observations, or let me just keep something smaller number. Suppose we have some 50 number of observations, right? We have 50 observations. Okay. Suppose we have 50 such observations. In hierarchical clustering, first of all, we are considering every observation is a separate cluster. Okay. First of all, in hierarchical clustering, we are assuming every observation is a separate cluster. Okay. Make sense? Make sense? So in the beginning, if we have 500 observations, we have 500 clusters, right? If we have 10,000 observations, we have 10,000 clusters in the beginning. If we have 1 million records, we have 1 million clusters in the beginning, right? So in the beginning, hierarchical clustering will treat every observation as a separate cluster, correct? Now, it will start clubbing the observations with respect to their similarities, the Euclidean distance and the linkage properties, right? It will start clubbing the observations with respect to their similarities to other observations, right? Possible? We can do this thing? Yes, we can simply club the observations as per their similarity or something, right? So now we will be having some lesser number of observations here. We will be having some lesser number of clusters here. We had 50 clusters in the beginning, but now we have some lesser number of clusters, right? Make sense? Now, again, it will combine the clusters with respect to their similarities, right? So this clubbing thing will keep on going until we have everything as one cluster, right? This clubbing thing will keep on going until everything is a single cluster, right? Only one cluster. So we will keep on clubbing the clusters. We will keep on creating this hierarchy until we combine everything as a single cluster. So there will be a hierarchy tree here. Yes, correct. There will be hierarchy tree here. Yes, is it clear everyone that there is going to be a hierarchy tree here? Perfect. Now once we have the hierarchy tree, we actually cut the branches to get the desired number of clusters. Suppose we want 3 clusters. So this tree will be cutted. We will cut that tree. We need to cut that tree to get the 3 clusters. Only 3 branches at the top. And that's how we will get the 3 clusters. Right? How hierarchical clustering is working, based on their similarities and everything, we will create a hierarchy tree like this. And suppose we want 3 clusters, we want 4 clusters, 5 clusters, whatever is the requirement, we will cut our tree from the top in order to get only 4 or 5 or whatever is the number of clusters required, only those number of branches. And we can divide the data into clusters by this approach also. Yes guys, we can easily divide the data into clusters by this. But there will be only even number of clusters. No, it actually depends. It's not there will be only even number of clusters. It completely depends upon the similarities in the root level in the first stage. It completely depends upon if they are similar, then only they will get clubbed, right? Awesome. So that's the second method of doing the cluster analysis. Now, see this cluster, this hierarchical clustering is right now basically expensive approach, we can assume that this is going to take a lot of time in executions, right? Yes, this gonna take a lot of execution complexity, right? This is going to be expensive in terms of computational resources and execution time both. Yes. How do we need to know? I'll tell you. Basically, we can. I'll show you actually a possible case where hierarchical is going to help us and k-means is not actually giving a good result. But we cannot plot a huge dimensional data. So in order to see which type of algorithm is giving us the best accuracy, the only method is to implement both and see in which case we are getting a more accurate, insights. Because in unsupervised, we don't even have the accuracy to evaluate which is correct, which is not correct, right? We don't even have the accuracy to evaluate. So we just need to reach to end. We need to observe the end results, the insights, and whichever model gives the meaningful insights, that is what we go for at the end as a production model. But there are some things we need to know where hierarchical will help us and where k-means will help us. So I'll show you a small statistical example where hierarchical is giving us the best accuracy. Okay. The advantages, sure. Let me just give you a possible case. Okay. So suppose we have the data like this. Suppose this is how the data is distributed. That's the one cluster. Okay, suppose that's the cluster. And let me create another cluster like this. Yeah. Okay. Yes. Suppose this is the data set. This is how the data is distributed. If we use the k-means clustering, now we know the k-means clustering is centroid based, right? The k-means clustering is centroid based, so k-means clustering will give us the cluster like this: a centroid here, a centroid here, right? The k-means clustering will give us the cluster. The best cluster what k-means is going to get is this. But if we use hierarchical clustering is not the centroid based. Hierarchical clustering will go to each and every observation and it will check the similarity. So if we use the hierarchical clustering, we will get the cluster like this only. Yes? Yes? Okay. Now this is just to understand the statistical approach of hierarchical and clustering. Practically in the real-time data, it's not possible to observe a data like this. This is the two-dimensional x1 and x2, so we can plot and we can see. We can plot and we can see, but whenever we have a business case, when we have a business data, we don't get only two columns. We used to have a lot of columns, right? We used to have a lot of columns. So this is just to understand on a statistical perspective where hierarchical clustering can be helpful, right? There could be a possibilities where clusters, the centroids, cannot create a good model, right? Overall, the overall conclusion of this is that whensoever the clusters are not actually giving the good results, the hierarchical will stand out. Yes, guys? Perfect. So, got this k-means and hierarchical clustering, everyone? Yes, please let me know if the approach, the concept part of these two cluster algorithms are clear. In unsupervised learning, we need to check all facts. All facts as in, yeah, actually we need to check everything. Yes, we need to check everything. We need to check everything. Yes, please let me know what's not clear. If you have any questions, any doubt, anything is not clear, please let me know. Yes, please. Anyone, anything, guys? Can you explain? Okay, over others. What other algorithms we are referring right here? What other algorithms we are referring right here? The k-means clustering. So we have seen when we used the k-means clustering was creating a cluster uh, on the basis of a centroid, right? Yes. And in this data, the centroid way of creating a cluster is not giving a good cluster model, right? Right? But if we go one to one by one observations, we are going to get some good results, right? Right? Now is it clear that hierarchical is helpful? Hierarchical can give the better results when the data is actually mixed. When there is no clear separation, the centroid method will only, centroid method will only give a good cluster when there is a some sort of linear or some polynomial or some sort of separation in the data. Yes, they are concentrated to different locations. Then only the centroid method will work. In case if they are not concentrated that way, the hierarchical clustering is going to help us. Make sense? Because hierarchical clustering is going to one to each and every observations to check which one is the closer, and then it will create a group. Right? Getting it? Perfect. Yes, guys. Conceptual part of these two algorithms, k-means and hierarchical. Is it clear, everyone? Okay, now the case study we will be doing has some EDA part also, means we need to prepare the data before we create the clusters. So that's actually more interesting case study. We have the data set about the transactions and we need to create some components, some factors, some business factors from that data sets, and then we will be creating clusters over those components. So let's start. This concept part is clear, everyone, about k-means and hierarchical? Yes. If there'll be a question how k-means and hierarchical are different, we can answer that question, right? Yes, specifically for these k-means, the cluster analysis, k-means and hierarchical are the most common algorithms. How are they unsupervised? And what exactly is unsupervised? Yes, what is unsupervised? No target, right? We don't have any target here. We create a group without any target. Perfect. So let's do the case study, guys. So now let me upload today's day 11. Yes, I have updated the folder in day 11. You can download it from there. Yes, so please download everything that's there in day 11. Data mining is basically all about gathering the data, and carrying out some meaningful insights. So we cannot say it's not even a learning approach. Data mining is just gathering the information. We don't make a machine learn in that case. Deep learning are again the learning algorithms, more complicated, more complex learning algorithms that we use in order to make a machine learn. Not too much. It won't be too much. How I can view details? How can we see the size? Okay, yeah, 7 MB. Yeah, this won't be huge. This folder will not be huge. So let me also close the unnecessary files and open this. You need to open this file. Online detail k-means hierarchical clustering. So this has some huge code, so this is gonna take some time for the execution. Let me just delete. Let me execute it right now. Let me execute the cells right now. So meanwhile, we will discuss the pre-processing and other things. The algorithm part will get executed. Okay. So first of all, we just need to, in this case, we just need to, we have a data. Let's go through the overview, the problem statement. Online retail is a transactional data set which contains all transactions occurring between this date to this date for a UK based and registered non-store online retail business. The company mainly sells unique all occasion gifts. Many customers of the company are wholesalers. So right now we have the transactional data, the data about the transactions for a non-store retail business, right? E-commerce business here, right? We have the transactional data for an e-commerce business. Yes, we have a transactional data for an e-commerce business, and we need to create the customers. We need to create the customers based on RFM. Now, what is RFM? Recency frequency monitoring. We'll talk about that in more detail. What is RFM? How do we calculate the RFM? But as of now, we can understand that we have the data related to the transactions, and we need to create the groups of the customers, not the transactions. So this requires a lot of data pre-processing, because the data is related to the transactions. We have the transactional data, but we want to group the customers. So we need to transform the data with respect to the customers first. Make sense? So that's the first stage. We have the data, we have the information about the different transactions, right, for e-commerce business, and we have all the transactions for a given year, and we need to group the customers. So the very first step is going to be create or to transform the data with respect to the customers instead of transactions. Okay, right? Perfect. Now RFM are basically some factors, some business factors what we need to create about the customers. We will talk about the RFM in more detail, but first let's understand the data. So first of all, we are importing the libraries, K-means, Silhouette score. Okay, so before that, we are aware of all the libraries. These libraries are meant for the cluster analysis. The K-means clustering, right? This is the K-means clustering. To implement the K-means clustering, let me put Silhouette score. Okay, no, it's at the right place. Silhouette score is actually a score to decide the number of clusters. We'll talk about it. We'll see how Silhouette score works, what is the formula, and how do we read Silhouette score and how we finalize the number of clusters. So Silhouette score is basically a method to finalize the number of clusters. What should be the good number of clusters in K-means clustering only. So that's why we are importing the Silhouette score here. Then linkage, dendrogram, and cut tree. These three libraries are for hierarchical clustering. So we are importing all the libraries for K-means and the hierarchical clustering. Okay. Perfect. So we have imported all the libraries. Now we need to read the CSV file, but if in this case, if we see there is an encoding part. Now let me explain what is encoding. Encoding is actually the character set encoding. Like we have UTF-8, ASCII, ANSI. We have different types of character set encoding. If the data is encoded in some specific encoding, we don't have, the data is not in by default UTF-8 or it's not in ASCII, we will get that encoding part from the data provider itself. That is not something we need to work on. The encoding, in which encoding the data is available, if we want to read the data, what should be the encoding, that is something we get with the data provider itself. Yes, that is something we get with the data provider itself. So along with this data, we know we have been given this information that this data belongs to this specific encoding. So in case we want to read it, we should use that specific encoding. Okay, so encoding part, what should be the encoding for what type of data is not something we need to work on. We will be getting the encoding part along with the data provider. Correct? Perfect. So this is the data here. Invoice number that explains. Yes, that's going to be mentioned. We don't need to work. We don't need to, we don't need to work, or we don't need to explore the different encodings. we will be getting the encoding part along with the data itself, that this is the data, and if you want to read it, this encoding we should be using. So encoding is something we will always get it from the data provider itself. Okay? Clear? What is encoding? Awesome. Awesome. Now we have the data set here, invoice number, the stock code, about the product, what is the product, description of the product, how many quantities were there, the invoice date, unit price, customer ID, and country. Okay. Okay. Now see, invoice number, though we have in the problem statement itself, it's mentioned that data belongs to the invoices, the transactions. So by that statement, we can say invoice number is going to be the unique key, but it's not. Actually, we have repeated invoice number as well. If we see the top 5 records, we have the repeated invoice numbers also. Yes? But if the invoice number is repeating, what's changing in that case? The stock code means the product in the invoice. So what is the unique key for this product, for this data, guys? What's going to be the unique key for this data? No, it's not the stock code. Invoice plus stock code both are going to be unique, because a single product can be available in multiple invoices, right? A single product can be available in multiple invoices. Yes, but if we combine invoice number and stock code, we are not going to get any duplicate values. We are not going to get any duplicate values, right? So if we talk about the unique key, invoice number and stock code is going to be the unique key for the product, for the data set. Clear? Yes. So now the description of the product is there, quantity, how many quantities we are buying, invoice date, on what date, on which time, on what date that transaction happened, unit price of the product, and then we have the customer ID. Now see guys, the customer ID is actually the important feature for us, because we need to put the data based on the customers. So we will be working very close to the customer ID, right? But right now if we see, customer ID is a float value. Yes, customer ID is a float value. Okay. So we are not like, this customer ID is not a numeric column, means the statistics of customer ID like mean, average customer ID, or variance in customer ID, or any such standard deviation, percentile values in the customer ID is actually not helpful. Doesn't make any sense, right? Average customer ID, or standard deviation of customer ID, percentile value of the customer ID doesn't make any sense here, right? It should be like a category. It should be like a category. We have customers, the categories could be huge. We have huge number of customers, and the ID is actually identifying the customers. So it's not a numeric column for us. The customer ID is actually not a numeric column. Make sense? Everyone? Perfect. Perfect. Now let's proceed and let's analyze the data. So first of all, we will see the number of observations we have. We have 541,000 records, approximately 542,000 records, right? 542,000 records we have approximately. Huge amount of data, right? Great. We did the info, and this is what we are getting in an info. So from this info, we can see what are the missing values and everything in the data. We can check the missing values. Okay. So we have the missing values in customer ID, and we also have missing values in description, but description is something we can ignore. We are not going to use description in our case. So customer ID is a critical issue, right? We are having the missing values in customer ID, and that is something critical for us. Now, what should we use in order to treat the data from customer ID? What should we use? Okay, mod. Yes, anyone else? Drop them. Okay. This is actually telling us the percentage of data missing. Yes, what about others? Mod, drop them, or yes, guys, anyone else? Fill with some number. What number? In like how, which, what we can use to fill? So in that case also, if we fill it with 0, in that case also, all those missing data will belongs to a customer that has the ID 0. Only one customer, right? And that is going to give some false results. If we use mod also, we have 24% data missing, and 24% of the transactions will be made by one customer, right? If we use mod, yes, we need to drop. We will simply drop those records where customer ID is not available. We will be dropping where customer ID is not available. Okay. We will simply be dropping those records where customer ID is not available. Okay. Yes. That's huge. 24% is a huge number, but that is the only solution we have. That is the only method we can do. Clear? We will be dropping those rows, those observations where customer ID is not there. No, customer ID is unique for the customer, but it's not unique for this data. Customer ID is unique for the customer, but customer ID is not unique for the data. Now we will simply be dropping it here. We are dropping because it's almost 25%, and yes, exactly. So we are simply dropping the missing values. Now after dropping the missing values in customer ID, we have nothing as a missing, right? There is nothing in the missing value. Okay. If it has 0 to 5%, then also I would say we should drop, because customer ID is the key column for us. Customer ID is the most important column for us, because we want to group the customers only. Yes? Great. Great. So now we have treated the missing values, and now the data has 0 missing values. Clear till here? Okay. Now we will simply convert the customer ID to text to string, because we had already discussed customer ID should be treated as a category in our dataset. We have around 4 lakh records left, 400,000 records left. We have around 406,000 records left. So out of 406,000 records, if we check the unique customers, we have 4,000 or so. So that should be treated as a category. That's why we are converting it to the string. Make sense? Everyone? Perfect. Now we need to calculate those 3 factors RFM. So before we proceed, let's discuss about RFM. RFM. R stands for recency. F stands for frequency, and M stands for monetary. Monetary. How much money every customer is spending, how frequent the customer is, how recent the customer is. Actually, we can say d type equals to, yeah, that's also a way. We can also do that thing. We can also do that thing. But amount should be in text, numeric only, right? Amount should be in numeric only. The unit and the amount should be in numeric. Unit price and quantity. The unit price and quantity should be numeric itself. Yes. RFM, recency, frequency, monetary. Recency, how recent our customer is. Frequency, how frequent purchases. Or we can say, simply say the number of transactions we have for every customer. That's the frequency. And monetary, how much money a customer is spending. Monetary, how much money the customer is spending. Frequency, how many purchases the customer have made, how frequent it is. And recency, how old is the recent purchase for every customer, right? How old is the recent purchase for every customer? That's the recency, frequency, and monetary. Yes, now we need to create these three columns from the data. We have the transactional data, but we need to transform that transactional data in order to get these three factors about each and every customer. So what is recency, frequency, and monetary? Is it clear, everyone? Great. So let's calculate them. So this is the data. We have the quantity and unit price. So first let's create the amount column by doing quantity into unit price. Now we have the amount that has the quantity into unit price. So amount for every stock in a transaction. That's going to be the amount. Yes, amount column that will simply calculate the amount in every transaction. Clear? Then if we simply do group by customer ID and sum of amount, we will get the monetary factor. Retail.group by customer ID and the sum of amount will give us the monetary factor. What amount of money every customer is spending? Total money every customer is spending. Yes. Group by customer and the sum of amount is giving us the monetary factor. Easy? We can arrange it anyway. We can arrange it anyway. If we want to, analyze, we can definitely arrange it in any order. Okay? Yes. So is it clear, everyone? The amount, the monetary factor is clear? Okay. So if I simply use this code dot reset index, so it will create this existing index as a column and it will create a new index, right? This was the amount, but when we did reset index, the current index was stored as a column and it creates a new index, right? Easy? Yes, guys? Easy, everyone? Great. Now, we are just doing the same thing in a single cell, and this is how we have the monetary factor. RFM underscore N, that's the variable that is storing the monetary of every customer. Clear? Clear? Yes, guys. All good with the cell number 65, everyone? Awesome. Now, we need to calculate the frequency, guys. How can we calculate the frequency for every customer? Value counts, yes, smart. Group by and count, group by and count. Okay, now what should we count? What should we count? Invoice number. We should count invoice number. But we should count unique invoice numbers. So before we do group by and count, we should drop the duplicated invoice numbers, because if we see, the invoice number is getting repeated as per the stock code, but that's only one purchase only. The invoice number is getting repeated, but this is only one purchase. So we should not count these 5 invoice numbers as 5 purchases. This is only one purchase. So we should drop the duplicates in invoice numbers, and then we should count. Yes. Simple. Retail dot drop duplicates, invoice number, group by customer ID, and count invoice number. Okay. First, we drop the duplicates for the invoice numbers, then grouped with customer ID and counted the invoice number. So this is the frequency of every customer. This is the frequency of every customer. Easy? Why we are dropping the duplicates? This is also clear? Because, yeah, awesome. Awesome. Perfect. All good with monetary and frequency? Yes, guys. Anyone wants to explain why we are dropping the duplicates from invoice number? Yes, please. Anyone? Why actually we are dropping the duplicates from invoice numbers? Because we have duplicates. The invoice number is repeating for every stock, for every product. So if you see for this customer, there are lots of invoice numbers, but this is only one purchase. We should not count it as a 5 purchases. That was same invoice number. There were only 5 products, but the purchase was only one. Yes. Yes, if we don't drop, we will get the count of products the person have purchased. Yes, that's the frequency. That is the frequency. The number of transactions every customer has made is the frequency. Great. So that's how we have calculated the frequency. The same code we have used, and this is RFM underscore F is the frequency. Clear, guys? Frequency, everyone? Easy? Easy and interesting so far? Awesome. Now we have the monetary, and this is how the frequencies. So let's merge these two data frames with respect to the customer ID. What's the frequency telling with respect to the customer ID? Frequency is telling how frequent the customer is, how many purchases that customer has made in the entire time span. We have the data for 1 year. So this customer has made 2 purchases. Okay. Perfect. So we have the data set like this, and let's combine. I think where we are combining. Yeah. Here, pd.merge, RFM monetary, RFM frequency on customer ID and inner join. So this is the common data frame that is giving the entire information, the frequency and the monetary both. Yes. Merge function, merging the recency, frequency, monetary, and again RFM M and RFM F. The ID is going to be customer ID and the inner join. We will calculate recency. We haven't calculated recency. We will calculate recency now. Why inner join? Because we only want the data in which the frequency and amount is available in both the records, right? So we want inner join because we want those customers where frequency and monetary both are available. Others we need to exclude. Actually, in this case, see, we want to create the groups of the customers with respect to the frequency, recency, and monetary. So we can only create if we have these three factors for the customers. Yes. So we created a data frame where only monetary is there. We created a data frame only frequency is there for the customers. Now, while combining the two data frames, we are simply saying that just combine the data, and wheresoever the frequency and monetary, yes, the frequency and monetary available for the both are available for the customers. Okay. Two transactions. The another transaction could be a refund. Good question. If we see the transactions for this customer, there is a negative amount for that customer. This customer must have taken some refund. That's why the total amount is 0. Clear? Is it clear, the inner one? Awesome, guys. So this is how the data looks like. Now let's calculate the frequency. So before we calculate the frequency, we need to understand what is frequency. Frequency means how old the recent purchase is for every customer. How old the recent purchase is for every customer. And how old we will calculate with respect to the days. Yes? How many days old the recent purchase is for every customer. So in order to calculate this, we will be having some date, let's suppose last date to calculate the difference. So let's suppose we are using the last date of entire data set as a last date. Okay. Yeah, present date we can use, or let's use the last date that is available in this entire data set. Right? Last date is the last date of the entire data set. So for every transaction, we will do last date minus invoice date. So we will get how old every transaction is. Yes, after doing this, we will get how old each and every transaction is from the closing day. Yes. This way, we will get how old each and every transaction is from the closing day. Yes. Let's suppose we created it as a name difference. Okay. So diff is explaining how old each and every transaction is from the closing day. So if we again group the data with customer ID and calculate the minimum of difference, we will get the recency factor. Group the data with customer ID and minimum of this difference will be the recency. Yes. Yes, minimum difference for each customer ID. That is the age of most recent purchase for every customer, right? If we calculate the minimum of difference for every customer ID, that will be the age of most recent purchase for every customer. How old the most recent purchase is for every customer. That's what we will get if we calculate the minimum of difference for every customer ID. Yes? Is it clear, everyone? Great. So now let's do it. So first of all, we need to convert the date column, that is invoice date. It's an object right now. We need to convert it to date, right? It's an object right now. We need to convert it to date time. Then only we can calculate the date, and we can do the subtraction and other things. So first of all, from date, or this is the last date we are referring. Last date is going to be the maximum, means the maximum, the most, the last date of this date column. So right now we are converting invoice date column into date time function, right? We are converting the invoice date column to date time format of the data type, right? By specifying DMY hours and minute as the format of time, and dot max will give the last date. Yes, that is 2000. Okay, this is 9 December 2011, right? 9 December 2011. Clear? Clear? So this is something we will be using from last date. This is something we will use as a last date. Okay? Perfect. Now we simply need to calculate the difference, that is last date minus invoice date, and we will get the difference. We will get the difference. I didn't get why we are using last date. In order to calculate the difference, we need to use something like from where we want to calculate the difference. From which date we want to calculate the difference? So we are using the closing day. How old the transaction is from the closing day. So that's why we are calculating the last date, that is the closing day. When this data is all, like we have the data with all give for a given financial year, for a given year only, right? So this is the closing day. We will be calculating difference with respect to the closing day. Yes, we can use current date. Yeah, we can use the current date if it's a recent data. The data belongs to year 2011. So we are simply using the last date here. Okay, clear everyone? The difference, this is the difference. So this transaction happened 373 days earlier. And this is the transaction on the closing day itself. Correct? So simple calculating the minimum of difference for every customer ID. Right? Yes. If we calculate the minimum difference for every customer ID, what happens if the data had, okay, in that case, we need to specify whatever is the format in the format attribute. If the data has some separate format, we will specify it here. Okay, so this is how we are telling what is the format of date in the data. So if it is in some other format, we will specify it here. Just give the format whatever is there. Only specify that format that is there. If you only have the month and date, remove the year from here. Here 01 or 02 can be month or so it completely depends on the entire data. We won't be having a single record, we will be having the entire data, right? So when we have the entire data, we should be having some standard, some standard format of the date time, what we are following, MMDDYY or DDMMYY. And whenever we have the entire data, we know if like the first value is exceeding more than 12, it's a date, right? If the second value is exceeding more than 12, that is the date. Yes? Yes? Make sense? Exactly, yeah. The data should be uniform. If the data, every record has different format, then we cannot use toDateTime function in that case. If the data is not in a uniform format, we cannot use toDateTime in that case, right? Perfect. So the minimum of difference is clear, everyone. So right now we simply executed this and we have the minimum of difference for every customer ID. Easy? Perfect. So we have the days and everything. Let's only extract the days out of it. .dt.days will only give the number of days. And here we go. We have the recency also. We did dt.days and we have the recency here. Easy? Awesome. And at the end, we simply have combined the data. What happened? I am executing the codes from the middle. That's why it's giving error. Yeah. So after we did the combination, we combined all the three data frames. Here we have our final data, the customer and frequency, recency, monetary for everything, right? This is the final data, what we have right now, and now we need to do the further cluster analysis. That is something we'll do after the break. Yes. Yes, guys, let's take a break and we have prepared our data for the cluster model now. Yes, it was a data pre-processing. Actually, the problem statement was also not too much explanatory. So most of the times that is not actually the case. We used to get the problem statement a little bit more, explained. So this will not happen when you will be working on some problem statement. Okay. So the polls are open, guys. Let's get back after the break. Hey everyone. Awesome. So we are all back and let's build the cluster model. So now the further thing is outlier treatment, and we can do the outlier treatment. I will skip this thing for you guys. Just do the outlier treatment and other things. Now after doing the outlier treatments, we will simply be scaling the data. Standard scaling. Okay. Now why we are doing the standard scale? We observed how k-means clustering works and also how that hierarchical clustering works. So this is also recommended a good to follow step to do the standardization before we follow any cluster algorithm. And based on their method, based on their approach also, we can we can imagine that standardized data will be more effective. If all the dimensions have standard scale, equal scale, then we are going to it's going to be more efficient. Make sense? Yes, guys. So we had RMF and we simply did the standardization, and now we will see how to create the models. So first of all, how do we create a cluster model? K-means, not any, for the specific cluster algorithms here, K-means and hierarchical. It's not for all the algorithms, but for K-means and this is good. It's good for KNN also, it's good for SVMs also. KNN and SVMs, right? Because they also work on the coordinates, they also work over the coordinate geometry, and where like wheresoever we have the coordinate geometries, it's always better to have all the coordinates in a same scale. I mean, it's not necessary, but it's better. Yeah, perfect. So now let's see how the cluster model is working. Simple create a k-means clustering, specify the number of clusters, how many clusters we want to create, and then dot fit function will simply create the clusters, dot label will give the labels. Okay, now how we came up with the three? How we came up with the three? So as of now, 2 is the most, the minimum possible cluster model, right? We will see the elbow point. We haven't discussed elbow point here. Right now, how we claimed 3, how we decided 3, because 2 is the minimum possible cluster model. And here also we have 3 factors. So this is actually not a rule if we have 3 columns. So let's create 3 clusters of it, or if we have 11 columns, so we will be creating 11 clusters. This is not like this, but right now we have 3 factors in consideration. So that is also a way, that is also somehow we can think to create to get a 3 clusters, right? But definitely this is not the final one. We will be following a proper statistical approach to finalize what should be the number of clusters. That is just a random start. Where should we start the cluster model? Okay. Yes, this is just a start. So we started as a 3. Why 3? Because 2 is the very minimum, bare minimum. We cannot have any cluster model below 2. So 2 is the bare minimum. We try to get one step ahead of 2. And 3 also, we are also, 3 is also favoring the number of factors we are having. So we have 3 factors. So that's how we can simply start a random cluster model, that is 3. But definitely we will be following proper statistical approach to decide what should be the number of clusters. Clear? Great. Now, okay, so we have given RMF data frame scaled, the scaled data for training a k-means cluster model. Dot labels, after training is done, dot labels will be which observation belongs to what cluster. We can see we have 0, 1, 2. So it will create 3 clusters and it will assign the label for every observation to what cluster every observation belongs to. So these are those labels. Clear? What are the labels? We have these labels for all the observations we have given in RFM scaled. So if the number of rows in RFM scaled are 4000, we will be getting 4000 labels. Make sense? Perfect. So let's just assign it to the data. And now this is the cluster label. These are the values. After we simply created cluster equals to k-means dot labels. So there is a new column cluster where we have all the labels. Understood? Now we will be doing the elbow curve method to calculate. The labels are, so this first customer belongs to the second cluster. Second customer belongs to the first cluster. Third customer belongs to the 0 cluster. Customer cluster, very similar. Right? Understood? Perfect. Now let's observe the elbow curve of deciding the optimum number of clusters. So SSD, sum of square of distances. SSD is basically we are simply creating an empty list of SSD and we are creating the values of K, means different types of cluster models we want to create. K is the types of cluster model we want to create. Okay. Yes. So we will be creating 2, 3, 4, 5, 6, 7, 8 and 9, these many clusters, and we will observe the SSD. Now I will explain what is the SSD, guys. So remember the heterogeneity and homogeneity concept? No, we haven't talked about the heterogeneity and homogeneity. Okay. So if there is a cluster, there are 2 clusters and within variance between the observation of the same clusters. Let's say there are 2 clusters, one is this and another one is this. So within distance means distance of the observation in the cluster itself. The distance of the observation in the cluster itself. If that distance is less, means the cluster is more homogeneous. Yes, guys? If the distance of the observation within a given cluster, if that distance is less, means the cluster is more homogeneous. Right? Yes, they are closely related, means they are similar. And that is a sign of a good cluster model, right? And see, if the distance to each other, not with respect to the centroid, to each other, not with respect to the centroid, the each other, how similar they are to each other. And if the distance between the two observations, between the observation of 2 clusters, if that distance is maximum, again it's a sign of good heterogeneity between 2 clusters, and that's also a sign of good cluster model. If this distance is maximum, it means the model is more heterogeneous, right? This cluster and this cluster are different. They are more different, and that's also a sign of good cluster model. Yes, guys? Understood? Clear? Okay. So if we talk about the between distance, so what this should be, maximum or minimum? Between distance should be maximum or between distance should be minimum? Maximum for a good cluster model? Yes, maximum for a good cluster model. but also it has a negative correlation with the number of clusters. As we keep on increasing the number of clusters, the between distance will start reducing, right? As we increase the number of clusters, the between distance will start reducing. No? Why max? Because if the between distance is more, it is more heterogeneous, right? Max because it is heterogeneous. Make sense? Perfect. So we also understand this thing that when we actually create a lot of clusters, the between distance is going to reduce, right? Yes. If we create a lot of clusters, the between distance is going to reduce. On a given data set only. Yes. So is it clear? For a good cluster model, we want between distance to be more, to be maximum. But as we increase the number of clusters, it's going to decrease. So this way, we should always pick the cluster model with the minimum clusters, right? So that this way, the model with the minimum cluster is the best model, but that is not correct. In order to get a middle ground, we try to look for an elbow curve. See, this is how it is actually reducing. This is how the between distance is reducing, right? That's how the between distance is reducing. And this graph also makes sense. As we increase the number of clusters, definitely the SSD, this value is called inertia, but we can understand it as a between distance only. This curve is an inertia curve. This is called inertia in statistics, specifically in cluster model. This is called inertia. Okay, but it is somewhat similar to the sum of square, the between distance only. Okay, SSD, the between distance only. And this curve also makes sense that this is going to reduce as per increasing value of clusters. So we try to observe the elbow point, and that's the best value of the optimum cluster, right? Right? Understood? The elbow curve to decide the optimum number of clusters? Sure. So this is the inertia curve. This is the SSD curve. We call it as a elbow method of deciding the optimum clusters. So if we see, we just need to point out the elbow point here. We just need to locate the elbow point, and this is where elbow is there, and that's at 3. Right? That is at 3. Okay, it is also at 4, but we discussed that between distance should be maximum. So if it is 3 and 4, we should be going with 3 itself, right? Make sense? Okay, so this is called elbow method of deciding optimum clusters. This is called elbow method of deciding optimum clusters. Okay? Clear? And this is how we decide what should be the good number of clusters. Yes, guys. Clear, everyone? Okay. Now, apart from elbow, we have one more method. Apart from elbow, we are calculating these based on the distance between points, between the different clusters. Distance of the observations in two different clusters. Yes. Yes. Perfect. Elbow curve is clear, everyone? Okay. So clear means clear from every aspect. What is this curve? Why we are actually locating the elbow point and everything. Because see what happens during the interviews. I have actually, I was taking an interview, and if I asked, how do we decide? I asked a candidate, how do we decide what should be the number of good clusters? The candidate responded by the elbow curve. So if I like, if you ask why the elbow curve, why exactly we want to point the elbow curve? Why not the maximum? Why not the minimum? Most of the candidates failed to answer this. Why we actually point the elbow? Why we don't go with the maximum, or why we don't go with the minimum? Or what if there is nothing like elbow? What should we do in that case? So it should be very clear why exactly we are pointing elbow here. Yes? Is it clear why we are pointing elbow? Yes, everyone? Why? Because see, there is it, not linear but non-linear relationship. There is some sort of relationship. The increasing value of number of clusters is going to decrease the distances, right? Where there is a elbow curve, the fall in a distance is less, right? See here, from this fall is this much, but here it is elbow, the fall is less, right? Yes. If there is more corner point of thing, the that's where we can point the optimum number of clusters. And after this we can see there is a linear fall. There is a linear fall, means almost continuous fall. Yes, there is almost continuous fall after this. Yes, there is almost continuous fall after this. Correct? Why we are actually pointing the elbow curve? And we can simply answer this way. Why we are actually pointing the elbow? Because it's always going to reduce. And we want a good cluster model with the maximum value of inertia. This way, we should be always going with the minimum cluster model. But that's not correct. That's not a right way. This way, we are always going to get cluster model 2. So that's why we try to point the elbow. Make sense? Yes, guys. Does this make sense, everyone? No, it won't be third always. It can be four, it can be five also. Depends on the different data set. It's not going to be third always. It can be four, five. Most of the cases, as per my experience, it lies somewhere between four, five, six only. Very rarely it exceeds than six, but more or less around four, five, six itself. 3.5, we are actually deciding the number of clusters. So 3.5 cannot be a cluster, right? We cannot create 3.5 clusters. Okay. Yes, that is actually the number of clusters. If there are no elbow points, then we need to intelligently use that cluster model where the inertia is decent, not too less. The cluster model should not be too less, and inertia should not also fall too much. If there are no elbow points, that's why we discussed what this curve is explaining, and what this curve will tell us about the goodness of a model, right? So if there are no elbow point, we can intelligently pick some number that has a decent value of inertia also, and the number of clusters is also not very less. We can do that thing. right? Perfect. Perfect. Awesome. Clear, guys? Elbow curve, everyone? Great. So after the elbow curve, we have another method to decide the optimum number of clusters. And what is the other method? That is silhouette analysis. Now, let's understand what is silhouette analysis. First, read this out. What is the P? Yes, read this out. What is the value of P? P is the mean distance to the points in the nearest cluster, not a part of, right? Now, P is going to explain heterogeneity or homogeneity. Read out what is P and what it is going to explain. Only two answers. What about others? Homogeneity. Okay. Mixed results. Heterogeneity. Homogeneity. Heterogeneity. Yes, guys. Okay. Another homogeneity. Heterogeneity. Again, P is the mean distance to the points in the nearest cluster that the point is not a part of. It's not a part of. Means the distance from other cluster, right? It is not part of that cluster. So other cluster. So this is going to be heterogeneity, not homogeneity, right? And Q is going to be homogeneity. We can see Q is going to be homogeneity. Okay. Now ideally P minus Q should be greater, right? P minus Q should be greater, right? This difference should be good. There should be a good, like it should be always bigger value. Bigger is this value, better is the model, right? And if this value is getting negative, or if it is getting value very smaller, so this silhouette score, this is the formula of silhouette score that lies between -1 to +1, right? And we can see higher is the value, better is the cluster model, right? Higher is the value, better is the cluster model. Yes? Understood the silhouette score formula and how exactly we can explain the formula also? Yes, guys? Understood the formula and what each and every element explains about the model. This is also clear? And this way also we understood that silhouette score should be good. It should be more for a good cluster model. So let's calculate the silhouette score for different cluster models. So this is what we are getting. So we are having the maximum silhouette score for 2, but again that's the bare minimum. So we will simply go one step more and we will pick 3. Right? Why we didn't pick 2? Because that's the bare minimum. There is nothing possible less than 2. So we simply picked the next, that is 3. Got it? Now again, in these cases, there are very less rules to be followed. We need to understand what these values are, what is the formula, and we need to decide intelligently what we should be picking, 2, 3, 4, or whatever we should be picking. Sometimes, let me give you other possible cases also. Sometimes if it's continuously decreasing, we also observe the difference of decrease, right? And at a point where it decreased drastically, we stop at that point. That is also a case. We often go with this kind of interpretation on silhouette score, right? If there is a continuous decrease in the silhouette score for having the more cluster models, now the fall, how it is decreasing, the difference. So suppose the difference is linear up to some extent and then it falls drastically. So we'll stop at that point and we will pick that cluster model. So that is a possible interpretation of silhouette score. Make sense? Right? So there are very less such rules to follow. That's why we need to understand what the silhouette score is explaining about the model, and then only we can intelligently pick the good number, right? Yeah, I'll explain the code. I'll definitely explain the code. As this thing is clear, silhouette score, how we are going to read the silhouette score, guys? Everyone? Perfect. Now let me just walk you through the code. The loop is clear. Is the loop clear, everyone? Creating a cluster model for a given value of clusters. Creating a cluster model for a given value of clusters. Easy? Perfect. Storing the labels for a given cluster model. Storing the label for a given cluster model. Yes? Easy? Okay. Now silhouette score is the function we have imported in the beginning. In this function, we have given the data and the cluster labels. This function will calculate that formula. This formula will be calculated by this function, and we are just storing this formula. We are just storing the silhouette score into a silhouette list what we have created here, and we are simply printing the silhouette score for every cluster value. Easy? Yes, because that belongs to a specific cluster. We have 5 clusters, so there will be average of 5 clusters, right? Okay, yeah. Which part? Where? What's not clear? We simply iterated for the different number of clusters. We created a cluster model for that specific number of cluster. We created a cluster model. We stored the labels, and in this function we have given the data and the label. So this function will simply calculate the silhouette score, and we are storing the silhouette score in the silhouette list for every possible model. Okay, that's the string formatting. That's how we place the information. 0 and 1. So in place of 0, number of clusters will be stored. See, for n clusters equals to 1, 2, 3. This variable is being placed here, and silhouette average is being placed here. That's the string formatting, right? Perfect. Understood silhouette score, everyone? Just to store, we want to we just like, if we finish the loop, if we finish this loop and we simply check the silhouette average, this has the average for the last uh, cluster model only, right? This will be the last cluster model only. And what if we want to have the other values also? So we need to store it somewhere. Yes. So that's why append. That's why append. Understood? Okay. 0.53, then 50, then 48. Okay, there is, and then it drastically dropped from 48 to 43. Okay, so I would say in this we can go with 4 also, right? And that in those values of silhouette score we can go with 4 as well, because see, from 4 to 5 it drastically dropped, and then drop from 5th is again not very huge. So we can use 4 also. We can also use 4 in that case. Okay. Perfect. Understood, everyone? Understood, everyone? Now, this is actually little, time taking process because we don't have something to evaluate whether our decision is correct or not. So to be very sure, very confident whether we have made it correct or it still needs some more clarity, we need to get to the end result first. We need to observe those insights. If we are getting a meaningful information, then we can say, okay, the model is useful. Otherwise, we need to go back and we need to again play with these clusters and other things. Make sense? Time taking, tedious process. Perfect. Awesome, guys. So, Silhouette score, how do we decide the optimum number of clusters? Everything is clear? Awesome. Awesome. So now, finally, we are creating the cluster with the number of clusters 3. We are finally creating a cluster model. Okay, this way we can actually calculate the cluster centroids for the 3 clusters. So these are the centroids for 3 clusters, right? So this way we can calculate the cluster centroids also. K means dot cluster centers will give us the centroids. Yeah, I'll just show you the analysis. I'll just show you what we can understand from these clusters. Okay, the cluster centers make sense? Clear? Cluster centers are clear, everyone? Perfect. Clear, everyone? Now, we have simply placed the cluster ID in the original data we have where we have amount, frequency, and recency in their original scale, not the standardized one. So we have given the cluster ID and now we are plotting. So see, this is the amount factor. Okay, this is the amount factor. We have 3 clusters. Cluster 0 and cluster 2 look similar, but if we see the people in cluster 1, these people have made no refunds, right? Means they are not actually costing the company. Their overall amount is not below 0. So these people are not costing us, right? They are giving some business. They are not costing us. They are actually giving some business. And we also have our prestige customers here. So if we talk about the amount, the customer in cluster 1 are the most important customers for us, right? Right? Similarly, if we check the frequency, again cluster 0 and 2 look similar. Cluster 0 and 2 look similar. One is the best. Now we like this might create a question why we are creating 3 clusters if 0 and 1 are similar. 0 and 2 are similar. In earlier also they were similar. Here also they were similar, but they must be different in the third factor, that is recency. Now we can see in recency, again the customers in cluster 1 and cluster 0 are good, but not in cluster 2. The customers in cluster 2 are old customers, right? They haven't made any recent purchases. But the people in 0 and 1, they are the active customers. We can say these are our active customers, but these are very old customers. Make sense? Make sense? So this way we can say the cluster 3 number, 3 groups are best, right? We created 3 groups and we are getting significant information. We are getting significant information on every group, on every factor, right? Yes? Then let's proceed. Okay, now let's see how the hierarchical clustering will work. Okay, so in a hierarchical clustering, there is a small concept of linkage. Now, what is the linkage? Linkage is how the similarity between two clusters will be calculated. So the first way of linkage is single linkage, in which we will use the minimum distance between two clusters as the similarity. Remember, we need to club the groups. So how do we decide whether we need to club or not? We need to calculate some metric. We need to use a metric to calculate the similarity or dissimilarity. So that metric is the linkage, and there are different types of linkage to calculate the similarity. Single linkage is one way to calculate the similarity between two clusters, and in case of single linkage, we use the minimum distance between the two clusters. Right? Easy? Single linkage of hierarchical clustering, guys. Perfect. Similar to the single linkage, we have complete linkage where we use the maximum distance. See, this is the dendrogram we are getting. This is how the customers are getting clubbed within the different levels. But now, why this is not very clear, and this is not readable, because the number of observations are very huge at x-axis. This is a dendrogram. We call it as a dendrogram. This is a dendrogram, and we call it as a dendrogram. And this is what hierarchy tree it will create. And the tree what we were discussing about in hierarchical clustering. So this is that hierarchy tree here, and we call it dendrogram. Clear? So apart from single linkage, we have complete linkage where we use the maximum distance. And this is how the data looks like in case of complete linkage, right? And similarly, we also have the average linkage. That is something we use maximum, and this is how the data looks in average linkage. The average distances between all the observations, average distances between all the observations. So this is how average linkage looks like. It will definitely take a lot of time to execute. I have executed this cell in the beginning of the discussion, and now that's why we get everything already executed. We use this average. Most of the times we use average here only. The formula, sure, this is the average of all the possible distances, dxri dxsj, where I and j belongs to the different iterations, r belongs to this cluster, s belongs to this cluster, right? So dxri xsj means distance of all the x to all the all the x from r to all the x from s. All the distance, like if this is the observation, let's say this is r1, this is r1. So distance of r1 to s1, s2, s3, s4, s5, s6, then distance of r2 to all the s, right? Average of all these distances is what we are calculating with this formula. Clear? Great. So this is what we use maximum, that is the average distance between the clusters, and the formula linkage function we have already imported, given the data, specified the linkage method and the distance metric. It will simply create the merging, and that's how our dendrogram looks like. The linkage will simply create a dendrogram. Easy till here? The distance metric, what type of distance we want to use. Okay. Now we are not visualizing the clusters here. This is how the dendrogram will be there. Now we need to cut this tree in order to get the desired number of clusters, right? Remember we were discussing at that time also. Once we have the dendrogram, once we have the hierarchy tree, we will cut the tree to get the desired number of branches at the top. So there is a cut tree function that will cut this tree to get the desired number of clusters. Clear? Now we have calculated the labels, but right now the labels are somewhat like this. So we can simply do the flatten and they will be in single dimensions. We can simply flat them and they will be in a single dimension, right? Yes, the codes from 105 to 108. Clear everyone? Yeah, Rebel also we can use. We can also use reshape. Awesome. So now we simply added the cluster labels from hierarchical to the data and we are analyzing the clusters. Now we can see in hierarchical the clusters are more different, right? The clusters are more, ndim is number of dimensions we have. So this data was two-dimensional. This is two-dimensional data. So ndim tells the number of dimensions of the array. So this is two-dimensional array. So it says two dimensions. Okay. Clear? Perfect. Now, now this is the three clusters. These are the three clusters here. And we can see in hierarchical clustering, we are actually getting more separate clusters, right? That is what we observe in the dendrogram. That is what we observe in a dendrogram. But this is not something giving us the real information. Not very sure that this is the minimum value and this is the maximum value, right? The data is distributed with respect to the index. The data is distributed with respect to the index. This could also be a more fruitful than this. So how do we actually get it? Which one is more fruitful and which one is not? By observing the box plots. Why are the labels in 0 and 1 if we have 3? No, labels are not in 0 and 1. Labels are 0, 1 and 3. Labels are obviously in 0, 1 and 2, not 3. 0, 1 and 2. See, then only we are getting these three clusters. The labels are there in 0, 1 and 2. Right? Array was showing 0 and 1. Oh, there are some dots also. We have 4,000 records. Array cannot display all the 4,000 records, right? Perfect. Perfect. Okay. So yes, we can see here that the clusters in hierarchical clustering are more separated. We can see the three clusters are identical here. This is completely separate than this. This is completely separate than that, right? Let's see the other one. This is also identical. And let's see the third one. This is not actually identical. Means if we talk about the recency, we are not getting anything good if we talk about the recency. But the frequency and monetary is something brilliantly being explained by a hierarchical cluster model, right? Okay, that could be a possibility. Chrome itself is a RAM eater, and if we run a heavy programs on the Chrome, it's gonna it is gonna take over every possible piece of memory on the system. Okay. Yes, guys. So this entire cluster model is clear, everyone? The cluster model is clear, everyone? Easy? Easy? Awesome. Okay, now small thing that we need to observe. Though we have covered a lot of, we have covered a lot of algorithms, and we have gone through with possible cases also. So something what I have experienced in new learners, most of the people try to learn data science as a rule-based approach. If else kind of criteria. If the condition is this, follow this approach. Most of the freshers, even I have done this in the beginning. We try to understand the algorithms, the steps, the methods as a rule-based approach. Means if this is the scenario, we should go with this approach. But it's not actually rule-based. We need to understand every step, like the way we discussed silhouette score, the way we discussed elbow curve, the inertia. Then only we can make a good decision, right? And this applies for each and every algorithm we have discussed and we are going to discuss in future. There are very less hard and fast rules in data science, very less. We need to understand each and every step very deeply, how exactly, what kind of operation, how it's going to treat our data, and how it's going to impact the end result. Then only we can take a right decision. Make sense? We also have experienced lots of such cases now. We have also experienced lots of such cases where the rules are not actually what we are following. Observe the case of our missing values treatment here. We dropped the missing values in customer ID because in that case we cannot follow any rule. We cannot use any rule to deal with the missing values. We need to understand the column significance. What exactly is this column? What exactly that column explains in terms of business, in terms of data, right? And if we are using mod, let's say if we say that that's going to be a category, right? So ideally in categories we use mod. We can use mod, but there is a problem while using mod in filling the missing values with customer ID. So we dropped, right? Right? Make sense? Yes, guys? Make sense? So there are hundreds of such cases where we will not be following any rule. There are hundreds of such cases where we will not be following any rule. Now, what is the way how we can actually decide how we can make a good decision? By knowing the exact method, what exactly each and every step, what exactly each and every method is doing with the data. Right? There are lots of courses, there are lots of lessons and methods and programs also available on the internet. They follow a rule based learning, like if this is a scenario, go with this is a scenario, go with this. But practically in data science, we very less we follow those rules. We need to understand the data, we need to understand the case, we need to understand what is expected, then only we can take a decision, right? Make sense? Yes, guys, does this make sense to everyone? And that is also the reason we have spent a lot of time in understanding the mathematics and the concepts of every algorithm, right? That is also the reason we have spent this much time in understanding the concepts and the mathematics, because that is the only important thing. That is the most important thing in data science. The coding is uh, anyone with the basic knowledge of programming can implement, right? If we talk about calculating this linkage, there is just a function in which we have given the parameters and here is the result. Only a function specified the parameters, we have a dendrogram. Another function give the number of clusters, we have the result. That's how easy the programming is. And anyone with the basic understanding of the syntax can implement this. Yes? Yes, guys? But how exactly this dendrogram is being created? What this dendrogram means? What we are going to read out of this dendrogram? What these values actually explains about the algorithm? That's where the catch is, right? Make sense? Perfect. Perfect. Awesome. So that's about the unsupervised learning. Next class tomorrow we will be doing time series forecasting. We will be doing time series forecasting from the next class. Okay. That's again not a very huge topic. We can easily do it in one class. Okay, we can easily do it in one class. So if we were able to do it before the time, we will be doing recommendation engines also tomorrow. If we were able to finish the time series forecasting before time, we will do the recommendation engines also tomorrow. Yes, guys. Okay, so how many of us are feeling more confident on algorithms now, on machine learning and the different algorithms now? Yes? Are we gaining that confidence of picking a data in the problem? Yes? Yeah, that's enough. See, if right now we should be at a stage where if we are getting some data and we are getting some problem statement, the possible scenario should come up in our mind. Like before we started the previous week, during the state during the discussion what all we did in the last week, we were not at this stage that if we have some data and we have some problem, we got some possible scenarios how to solve that. But right now we should be at this level that if we get some data and the problem, the possible scenarios, the possible ways in order to deal with that data with the different algorithms and steps should come up in our mind, right? And I hope we all have gained that confidence by now. Yes, guys. Exactly. Yeah, application needs a lots of practice, and we will only gain that grip by implementing, by writing the code. That is also a very common mistake a lot of people do. We understood the problem, we just scroll through the codes and we scrolled, okay, yeah, this makes sense, this makes sense, okay, we can follow this. Everything is clear, done. This, yeah, if we only study and if we only understand the code and everything, it will be clear. We can easily, like right now we have discussed everything in this file. If we'll look back at all these codes, if we'll simply scroll and see what's happening, it will be clear, it will be definitely clear. But if we'll try to implement the exact same thing, you might face some difficulties. So we should break few keyboards. We should implement the code. We should start writing the codes instead of just doing copy paste in the beginning. So if we are actually learning, if we are in the initial stages of this programming and all, we should write the code. We should type. We should follow the entire programming pattern, right? Yes. Make sense, everyone? I hope this will help. If anyone is facing any difficulty, any challenge, start solving the same problem what we do in the session. Don't go for anything new as of now. Even if you have understood everything, but still try to rewrite the code and solve it again. Okay? Perfect. It will require some time. Definitely, it will require some time. And also, most of us are already working, so it's quite difficult as well to manage the study and the work all together. But try to do some little efforts apart from these sessions. Half an hour or 1 hour maximum, not more than 1 hour. 1 hour daily is enough, guys. 1 hour daily is enough. Yeah, I can definitely understand that. It's very difficult to manage the studies and the work all together if we are not working somewhat related to what we are studying. If that's not the case, it's quite difficult. Right? Perfect. Anyone, any questions? Sure. The final output is this, the different clusters. Here it is. This is the k-means, and this is the different clusters on different factors, monetary frequency and recency, the final output. Clear? Clear, everyone? Perfect. That's everything. So if we have no questions, we are good to drop off. Thank you, everyone. Thank you all. In the project data set, the data is in form of abc.text. Sorry, in which project? Uh, can you please navigate me on which specific project? I like in assessments there is no such project in which we have .txt. So is it comma separated? .txt is a comma separated. If it is a comma separated, we can simply use .csv read csv to read the txt file also if it is comma separated. Is it comma separated? .text is comma separated? Okay. So have you checked .txt is comma separated or not? If it's not comma separated or if there is any other separator, if there is any other separator, in read CSV function we can specify the separator. If the comma is not, if the file is not separated with comma, see this is the read CSV function, we have a separator. So we can give whatever is the character for that separation. Okay, .dat file. So you must be going through with 11.3 self-learning, 10.13, 10.13, 10.13. Here it is. This one? Yes. Then Okay, for data science project. Okay, so let me give you an idea how we can do it. Just try to identify what is the separator. Just try to identify what is the separator. Okay? Okay. So I won't be having the access for that program. Try to identify the separator. Simple, try to identify what is the separator and give that separator in read CSV function. It will work. Here there is a separator attribute. Just use the separator, it will work. Okay, what separator you have specified? Yeah, wait a sec. Okay, does that work? Read table specified the separator. Header is this, t type, np, okay. Encoding, that's the encoding, and engine equals to Python. Okay, in this case, let me explain what we need to do in this case. The data is not actually formatted here. The data is not actually formatted here, so we need to tell every piece of information to Python while reading the data. What should be the separator, what data type should we use for every column, the encoding, and engine equals to Python is something default, right? This is the case where data is not actually sorted. The data is not actually organized in the way where Python can read and understand. So we need to tell every piece of information. So this is the code right here. Pranay shared this code. Yeah, yeah. So here we have like headers equals to none means column has no headers. Names, we have specified the names of the columns after the separation, and also the columns of every name, movie ID, title, and other things. Sure. If I again try to explain it, let me copy this code on my notebook. Okay. Separator. Header is if the first row of the file, if the first row of file is the column name on or not, right? If the first row of file is column name or not. So it said none means the first line or the first row is not the column name. So what are the column names? This is how we specify the column names. Okay. Perfect. Now this is what we tell in which data type we can specify the which data type we want to read each and every column. So movie ID should be integer, title should be string, genre should be string. And at the end we specified encoding the same way what we have given in our current data set also. And engine is Python, that's the default one. Now this makes some sense? Yes? Somewhat better? Awesome. Awesome. Sure. Perfect, guys. Thank you, everyone. Good night. Good night, all. Bye-bye. Take care.
Hey everyone, that was a great session. I request you all to please provide your feedback as well. The survey link has already been shared in the chat box. So please do that, guys, and please meet up in the next session as well. Please join your next session on time as well, okay? All right, we'll see you around in the next session, everyone. Have a good night, and yeah, please keep learning. Thank you, everyone. Bye-bye.